Glass is a material that has been used by humans for thousands of years. From the earliest days of civilization, people have been using glass to make windows, mirrors, and other objects. But what makes glass so special is its transparency. Glass is a solid material, but it allows light to pass through it as if it were a gas or a liquid. This property is known as transparency. But what is it about the nature of glass that makes it transparent? To understand that, we need to look at the atomic and subatomic level of the material. First, let's look at the structure of glass. Glass is made up of silicon dioxide, which is a combination of silicon and oxygen atoms. These atoms are arranged in a repeating pattern, known as a crystal lattice. In a crystal lattice, the atoms are arranged in a regular, repeating pattern. This is what gives crystals their characteristic symmetrical shape. But the crystal lattice of glass is different. It is disordered, meaning that the atoms are not arranged in a regular pattern. The disordered nature of the crystal lattice in glass means that when light passes through it, the atoms do not scatter the light in the same way that they would in a crystalline material. Instead, the light is able to pass through the glass without being scattered, which is what allows us to see through it. In a crystal, the regularity of the lattice causes the light to be scattered in many different directions. As a result, the light is not able to pass through the crystal in a straight line, and the crystal appears opaque. But it's not just the structure of the crystal lattice that determines the transparency of glass. The behavior of electrons within the atoms also plays a crucial role. When a photon of light hits an atom, it can interact with the electrons of the atom. This interaction can cause the electrons to be excited to higher energy levels. When the electrons drop back down to their ground state, they release the energy they absorbed in the form of light. This is known as fluorescence. In a solid material, the electrons are not free to move around like they are in a gas or a liquid. Instead, they are bound to the atoms of the material. This means that the energy of the photon must be just the right amount to excite the electron to a higher energy level. If the energy is too low, the photon will pass through the material without interacting with the electrons. If the energy is too high, the photon will be absorbed by the material, and the light will not pass through. The energy of a photon is directly related to its wavelength. Visible light has a relatively low energy and long wavelength, while ultraviolet light has a higher energy and shorter wavelength. The electrons in the outermost orbit of the atoms in glass are not tightly bound, and they can easily absorb the higher energy of ultraviolet light. This means that when ultraviolet light hits the glass, it is absorbed by the electrons and not able to pass through. On the other hand, the electrons in glass do not absorb the lower energy of visible light as easily, which means that it can pass through the glass without being absorbed. So, the transparency of glass to visible light is due to the fact that the energy of the photons in visible light is not high enough to be absorbed by the electrons in the glass. It's also worth noting that not all types of glass are transparent to the same range of wavelengths. Some glasses, such as UV blocking glass, are specifically designed to block ultraviolet light while still allowing visible light to pass through. These types of glasses are specially treated to create a thin layer of metal or other substances on its surface that absorbs ultraviolet light and prevent it from passing through, while still allowing visible light to pass through. In summary, the transparency of glass is a result of a combination of factors. The disordered nature of the crystal lattice allows light to pass through the glass without being scattered. And the behavior of electrons within the atoms allows light to interact with the electrons in a way that allows visible light to pass through the material and not ultraviolet light. Understanding the complexity of something as seemingly simple as a piece of glass is a reminder that even the most basic phenomena can be deep and profound when we take the time to understand them. Thanks for watching.